You know the feeling. It's a beautiful Saturday morning, and you step out onto your balcony.
Yeah, or maybe it's this massive commercial deck at your building.
Right, exactly. You're holding that first cup of coffee, you lean on the railing, shift your weight, and you look down.
And everything looks completely fine.
Yeah, the vinyl surface looks clean, the boards feel completely solid under your feet.
So naturally, you just assume that everything is perfectly safe, right?
Exactly. I mean, it's basically just an outdoor floor. You sweep it, you wash it, and you completely forget about it.
But see, that assumption is precisely what corners, property managers, strata councils, and, well, regular homeowners into these massive financial liabilities.
And serious safety hazards, too.
Oh, absolutely. Relying on the surface appearance to tell the structural story it just ignores the reality of what a deck actually is.
Which is what we are unpacking today. Welcome to this deep dive.
Thank you. I'm excited to get into this.
So our mission today is to completely transform how you look at your deck. We are pulling from this really fascinating guide by the Deck Safe Inspections Division over at Rain City Decks.
Yeah, and their foundational argument is that a deck is a highly complex structural system.
Right. They argue that the most dangerous part of your building might just be the one you trust the most.
Which is wild to think about.
Yeah.
But if you think of a deck as essentially a flat roof that people walk on,
Right.
It's subjected to these massive dynamic loads, and it's just relentlessly battered by harsh weather.
So the most serious dangers almost always start entirely out of sight, beneath that seemingly perfect surface.
Exactly.
Reading through their materials, I actually couldn't help but think of a deck like the skin of a commercial airplane.
Oh, that's a really good way to put it.
Right, because when you board a flight, you just see smooth, painted metal.
Yeah, it looks pristine.
But if the internal struts and the rivets underneath that skin are corroding, well, the smoothness of the paint doesn't matter one bit.
The structure is already compromised.
Exactly. The real threat to your safety and, your wallet is lurking in the internal mechanics that you can't easily see.
The airplane skin analogy works perfectly because it really highlights the difference between just cosmetic wear and actual structural failure.
So to understand why we can't trust the surface, we really need to look at the specific physical symptoms.
Right. We need to know what indicates that those internal mechanics are failing.
And the Deck Safe Guide lays out this very practical warning sign checklist, which they categorize by the urgency of the threat.
Which is so useful because, if you are managing a multi-unit building, you obviously cannot just tear up the waterproofing on 20 different balconies to check the wood.
Yeah, that would be a nightmare. You have to read the symptoms instead.
Exactly. You need to know what a structural heart attack looks like from the outside.
So let's start with the absolute top of their list. What are the high priority warning signs?
So the most immediate red flag is a soft or spongy surface.
Oh, I hate that feeling. You expect a floor to, push back?
Right. When you step down and the floor yields even just a fraction of an inch, it means the plywood substrate is failing.
That's the thick layer of wood directly beneath the vinyl. Right.
Exactly. It means it has fundamentally lost its structural integrity.
So it's basically just turning to mush.
Yeah. It means moisture has been trapped in that space long enough to actually dissolve the glues holding the plywood layers together.
Oh, wow.
Or rot has just consumed the cellulose in the wood itself.
Yeah.
So it is no longer a solid sheet. It's just a wet sponge.
That is terrifying. What else is on the high priority list?
Other high priority indicators include sagging deck areas.
Which means what exactly?
It tells you that massive joists underneath are physically warping or breaking under the load.
That is definitely not something you want to ignore.
No, absolutely not. They also list unstable stairs, which usually indicates the framing stringers have rotted out.
Okay, that makes sense.
And critically, loose railings. We will definitely get deeper into that one later.
For sure. But if any of those symptoms are present, it basically means the deck is actively communicating that its internal bones are broken.
Yes, it is an emergency at that point.
I want to talk about the next tier down on their list, though, because this is where I think most people, myself included, get kind of complacent.
The medium to high priority signs.
Right. They list water pooling as a medium to high priority warning sign.
Yes, they do.
But, if I see a giant puddle sitting on a deck for a couple of days after a heavy rainstorm, it is really easy to brush that off.
Because it's outside. It's supposed to get wet.
Exactly.
Yeah.
At what point does a puddle cross the line into an actual structural emergency?
Well, we have to look at the physics of how water behaves when it is trapped.
Okay, lay some physics on me.
So a deck is fundamentally designed to shed water. It must be sloped away from the building.
Right. To let gravity do its job.
Exactly. When water is pooling, it means the slope has failed, or maybe the drainage is clogged.
So the water just sits there.
It does, but the real danger is hydrostatic pressure.
Hydrostatic pressure, so it's not just resting there.
No, not at all. The physical weight of that standing water is constantly pressing downward. It's actively searching for a microscopic weakness in the vinyl membrane or the caulking.
So it's essentially pushing its way through the airplane skin, to use our analogy.
Constantly pushing. And the moment it finds a pinhole, like a tiny crack in the vinyl caused by thermal expansion, which is another medium-high warning sign, by the way.
Oh, right, because it expands and contracts over the years.
Exactly. Once it finds that pinhole, that hydrostatic pressure forces the moisture inside.
Once it's inside.
It cannot evaporate. It just sits in the dark and eats the wood.
Wow. Okay, so what about the medium priority signs? They list rusted fasteners.
Yeah, rusted screws or bolts.
See, if I'm walking around a deck that's 10 years old, a rusted screw just looks like normal weathering to me, like normal wear and tear.
Sure, it looks harmless, but a rusted screw isn't just an ugly piece of metal. It is a localized microclimate of wetness.
A microclimate of wetness, that sounds very bad.
It is. The rust means moisture is lingering in that specific hole. It's penetrating the wood fibers around the thread of the screw.
So it's rotting from the inside out.
Exactly. And as the rust expands, it actually crushes the surrounding wood fibers, which loosens the connection over time.
But to address my point about brushing things off as normal weathering, where is the line?
The source provides a very definitive threshold for this. If you notice structural movement, soft framing, loose railings, or visible rot, you have crossed the line.
So stop hosting the weekend barbecues immediately.
Immediately. You must restrict access and avoid heavy use until a qualified professional reviews it. The liability is just too high.
Which completely shifts how you have to look at this.
Right. A good inspection doesn't just ask, is the surface worn?
What do they ask?
They look at the geometry and the hardware and ask, is water finding a path into the structural cavity where it shouldn't be?
Let's talk about that architectural geometry, actually, because I think it's the key to this whole problem.
It really is.
I'll ask a question that might sound a bit naive, but it's something a lot of homeowners probably wonder.
Go for it.
Wood is obviously a highly durable outdoor building material, right? We've built barns and houses out of wood for centuries.
Absolutely.
Wood siding can last for decades in the rain. So why does a horizontal deck structure fail so much faster than a vertical wood-sided wall?
That is the million-dollar question.
Because if I have a waterproof membrane over it, shouldn't my deck be practically invincible?
It comes down entirely to how the architecture interacts with gravity.
Gravity. Okay.
Think about it. A vertical wall works with gravity. When rain hits wood siding, gravity instantly pulls it down and away from the structure.
Right, just runs right off.
Exactly. The water has very little time to penetrate. A deck, however, is a horizontal platform.
It actively interrupts the fall of water.
Yes. In wet climates, like British Columbia, which this source specifically references, it's a massive challenge.
Oh, right. BC gets a ton of rain.
A ton. And BC Housing, the housing authority there, explicitly notes how incredibly challenging wood decks and balconies are to construct safely.
Just because of their exposure to the elements.
Right. BC Housing actually identifies 4 non-negotiable principles for these outdoor structures: structural design, moisture management, material selection, and ongoing maintenance.
Because fundamentally, it is essentially a horizontal water trap.
Exactly that. Gravity wants to pull water straight down into the living space below, and your deck is the only thing standing in the way.
And water is relentless.
Completely relentless. The Deck Safe Guide details all these tiny entry points. It gets in through failed membranes, cracked coatings, poor metal flashing where the deck meets the house.
Like anywhere two materials meet.
Exactly. Open seams in the vinyl, penetrations where the railing posts are bolted down, and even gutters that back up and overflow into the joist spaces.
So once that water gets past the top layer, the source outlines this terrifying cascade effect.
Well, autopsy of the deck failure.
Yeah, walk us through the anatomy of that. When that hydrostatic pressure finally breaches the defenses, what actually happens inside?
Well, once moisture bypasses the membrane, it enters a dark, poorly ventilated cavity.
The perfect storm.
Right. It attacks the plywood substrate first, causing that spongy delamination we discussed.
The mushy floor feeling.
Yes. But gravity doesn't stop there. It continues to pull that moisture downward. It moves from the plywood into the joists.
Those are the thick horizontal beams that form the actual floor structure, right?
Correct. The wood absorbs the water, creating the absolute perfect environment for fungal rot to thrive.
Gross.
And from the joists, the water travels horizontally toward the building, heading straight for the ledger connection.
Okay, this is where the physics get really critical.
Very critical.
The ledger board is the massive piece of lumber that physically bolts the entire deck structure to the side of the building, right?
Yes. It is arguably the single most important component of the entire assembly.
Because it's holding everything up.
Exactly. A deck is essentially a platform leveraging its weight against the side of the house. The ledger board takes half of that sheer weight, the wood, the hot tub, the people, the snow, and transfers it into the wall studs of the building.
And it is held there by these heavy metal lag bolts.
Right.
So if water follows the joists all the way to the ledger board...
the ledger board begins to rot.
Oh, man.
Yeah. The wood surrounding those thick lag bolts just turns to mush. The bolts themselves begin to rust and thin out.
So suddenly that massive shear force is pulling on bolts that are anchored into nothing but wet compost.
Exactly. And when a ledger connection fails, the deck doesn't just sag. It physically detaches from the building and collapses.
That is a nightmare scenario.
And it gets worse. In multi-unit buildings, that trapped water often bypasses the exterior cladding entirely.
What do you mean?
It flows behind the stucco or the siding and leaks directly into the interior occupied spaces below the balcony.
So a failed seam on a third-floor balcony can mean a completely destroyed ceiling and, like, black mold in the second-floor living room.
Absolutely. The collateral damage is massive. The financial implications of a failed membrane often dwarf the cost of the deck itself.
Because you are suddenly dealing with interior drywall, insulation, electrical systems, all of it.
Right. It's a huge mess.
Okay, so we've established that the floor framing is under this constant siege from water and gravity.
Yes.
But if that framing gets compromised, the most immediate life-threatening physical danger to a person standing up there isn't necessarily the floor caving in.
No, it's not.
It is the failure of the very thing designed to catch you if you stumble, the railing.
Guards and railings are the absolute front line of life safety on an elevated structure.
And here's where it gets really interesting. Because if you have a loose deck railing, your first instinct is to just grab a wrench, right?
Right, just tighten the bolts at the base of the post.
But if that post is bolted into rotten, waterlogged wood, tightening those bolts is like putting a heavy-duty, expensive metal deadbolt on a door made of wet cardboard.
That is the perfect analogy.
It absolutely does not matter how strong the metal is if what it's attached to has turned to mush.
The wet cardboard analogy perfectly illustrates this illusion of safety, because the surface tension of the bolt might actually feel tight when you wrench it down.
It feels secure to your hand.
Yeah. You might even strip the remaining good wood fibers in the process, which actually accelerates the failure.
Oh, wow. So you're making it worse.
Exactly. And the lateral structural integrity, meaning its ability to stop a 200-pound person from falling forward, is practically zero.
That's terrifying.
The source highlights a specific British Columbia building regulation to really underscore the severity here.
What's the rule?
Guards are generally required anytime there's an elevation difference of more than 600 millimeters between the walking surface and the adjacent surface.
600 millimeters. So that's roughly just 2 feet.
Right.
If you can fall just 2 feet, the building code demands a structural guardrail.
Because a 2-foot fall backward or sideways onto hard landscaping or concrete can easily be fatal or cause severe spinal injuries.
Which introduces the whole deception of stability again.
Exactly. A railing can look beautiful, can be freshly painted, maybe feature those expensive tempered glass panels.
And it can still be a deadly trap.
Because of that wet cardboard door problem lurking underneath.
So what are the inspectors at DeckSafe actually looking for here?
They look for a very specific set of failures. Wobbly guard sections are the obvious ones.
Right.
But they also hunt for rusted brackets at the base, loose post bases, and unsafe spacing between the balusters.
But the underlying framing is the real issue, right?
Yes. The most insidious issue is rotten blocking below the posts.
Okay, let's explain blocking for a second, because you don't just bolt a railing post directly through the thin plywood surface, right? That wouldn't hold anything.
No, it wouldn't. A railing post acts as a lever.
Right.
When you lean on the top of a 3-foot railing, you are applying massive multiplied force to the base.
Like a crowbar.
Exactly like a crowbar.
Oh.
So to counter that, builders install thick blocks of wood between the joists directly underneath the post location.
So they are anchoring those bolts deeply into the framing.
Yes, that is the blocking. It transfers the lateral force of someone leaning on the railing down into the main structural bones of the deck.
And if water penetrates the bolt holes?
And that blocking rots then the entire railing system is fundamentally detached from the structure.
So tightening the screws from the top does absolutely nothing.
It achieves nothing. The underlying framing must be completely exposed, the rotten blocking has to be cut out, new wood installed, the membrane resealed, and the railing rebolted before anyone can safely lean on it.
Honestly, if you are sitting on a strata council right now or you manage a commercial building, this all sounds incredibly daunting.
Oh, I'm sure.
You might be listening to this thinking, every deck in my building is just a ticking time bomb of hydrostatic pressure and wet cardboard railings.
It's a lot to take in.
But if you can't just peel the vinyl back to look, how do professionals actually diagnose this without, taking a chainsaw to the deck?
Well, you need a structured methodology. You have to diagnose the health of the structure from the outside in.
Which is why specialized services like deck-safe inspections exist.
Right. They don't just guess. They trace the load path of gravity and water.
It's basically a forensic autopsy, but for a living deck.
Exactly.
The source outlines a very specific 5-step diagnostic process. Walk us through it. How does an inspector actually figure out what's happening in those dark spaces?
They start at the surface and work their way down to the foundation. Step 1 is the visual condition review.
So just looking at it.
Yeah, they're hunting for the surface symptoms, the wear patterns, the microscopic cracking in the vinyl, maybe rust stains bleeding from underneath the trim.
And then step 2.
Step 2 goes deeper into the structural assessment. They physically check the load path.
So they're looking at the bones.
Exactly. They inspect the posts holding the deck up, the beams transferring the weight, the joists, and they pay particular attention to that critical ledger board connection.
They are looking for the wet cardboard.
Right. They are looking for any deflection, any softness, and checking the integrity of the metal hangers holding it all together.
Okay, what's step 3?
Step 3 is the waterproofing and drainage review. This is where they evaluate the slope.
Checking if the water is actually draining.
Right. Is it being routed off the edge, or is it pooling against the stucco wall? They check the membrane seams and the metal flashing to ensure the horizontal water trap is actually sealed.
And step 4?
Step 4 is the railing and stair safety check. They physically test the lateral resistance and the attachment points we just discussed.
Checking the levers.
Exactly.
Yeah.
And finally, step 5 is where they synthesize all this data into priority recommendations.
So this is where they give you the bad news.
Well, they separate the immediate, life-threatening safety issues from the long-term capital planning items.
So what does this all actually mean for you, the listener? Once the inspector finishes tracing this load path and hands over the report, how do you know if you are on the hook for a budget-destroying rebuild or if it's just a weekend maintenance chore?
Well, the value of an inspection is that it translates all that structural data into a financial and actionable reality.
Okay, so it gives you a clear path forward.
Yes. The Deck Safe Guide outlines 3 possible verdicts that an inspection will yield. This framework is invaluable for, say, a strata council trying to allocate funds.
What's the first verdict?
The first verdict is maintenance.
Ah, the scenario everyone is praying for.
Exactly. It means the machine is functioning properly. The underlying structure is sound, surface wear is minor and cosmetic.
The railings have solid blocking.
Right, and the membrane is successfully repelling water. The prescription here is usually just basic drainage cleaning.
Like clearing out debris from the gutters.
Yeah, or maybe recaulking a small transition joint to keep things watertight. Very straightforward.
But what happens when they find the first signs of water intrusion? Verdict number 2.
That brings us to repair. This is targeted intervention.
So surgery, not an amputation.
Right. Repair is necessary when the inspector finds localized issues that haven't yet compromised the entire system.
Like small areas of rot at the edge of the plywood.
Yes. Or maybe the membrane seams are just starting to lift. It might mean a few specific railings need their blocking cut out and reinforced, or some stair treads need to be rebuilt.
So you are cutting out the localized damage to save the larger structural bones.
Exactly.
And the final verdict, which sounds like the nuclear option.
Yes. Replacement.
When do we hit replacement?
Replacement is the only safe option when the core mechanics of the deck have fundamentally failed.
So if the rot has spread everywhere.
If structural rot has spread through the joists, if that vital ledger connection is soft and pulling away, the deck is just fundamentally unsafe. It cannot hold the load.
And I imagine it's also triggered if the waterproofing is completely shot.
Absolutely. When the membrane has failed across such a large area that water is just freely flowing into the cavity.
It's past the point of patching.
It is. And the guide makes a vital economic point here too. Replacement is the right call when repair costs approach rebuild costs.
Yeah, that makes sense.
I mean, if you were getting quotes to spend 80% of the cost of a brand new deck just to chase rot, patch joists, and apply Band-Aids to a 20-year-old structure.
Economically, you are just throwing good money after bad.
Exactly.
Yeah.
It makes far more sense to tear it down and build a structure that resets the clock for the next few decades.
That really drives home the overarching theme of this deep dive.
It really does.
We started by acknowledging how easy it is to look at a balcony and just see an outdoor floor. But through the lens of this source material, the reality is undeniable.
A deck is a complex, heavily burdened structural machine.
It has to support the dynamic, shifting weight of human beings. It has to actively manage and route thousands of gallons of water.
And it has to survive decades of ultraviolet radiation, freezing temperatures, and physical impacts.
Understanding that mechanical reality is really the core takeaway for anyone who owns or manages property.
Taking a proactive inspection-first approach just completely removes the mystery.
Which is huge, because if you manage a commercial property or sit on a strata council, unexpected special levies are just a nightmare.
Oh, they're the worst. But a proper diagnostic inspection gives you a timeline. It allows you to budget and plan based on empirical data,
Knowing what the structure actually needs.
rather than just crossing your fingers or waiting for a contractor to give you a sales pitch when the railings are already wobbling.
Because the brutal truth is, by the time the deck is visibly falling apart on the surface, those internal structural bones have likely been rotting in the dark for years.
Yes. It shifts building management from a reactive panic into a controlled, predictable maintenance schedule.
So as we wrap up this deep dive into the hidden world of deck mechanics, we want to leave you with a final thought to mull over.
A bit of a bigger picture perspective.
Exactly. The source material paints a very vivid picture of a structure locked in an endless, brutal war against moisture and gravity.
We know that water is relentless,
And we know that horizontal wood structures are uniquely vulnerable,
which really forces us to look toward the future of how we build entirely.
especially with climate change.
Yes, as climate change accelerates, we are seeing a significant increase in extreme weather events. Cities are experiencing heavier, more concentrated torrential downpours.
So the elemental stress on these structures is only going to intensify.
It is, which makes you wonder about the long-term viability of wood for these applications entirely.
It raises a very provocative question about the future of building codes, honestly.
Definitely. I mean, even the most perfectly designed, beautifully constructed wood-framed deck is ultimately destined to lose its battle against hydrostatic pressure and rot.
Are traditional wood frame decks going to become a thing of the past?
It's possible. Will future building regulations eventually force developers in wet climates to abandon wood entirely for elevated horizontal structures?
Like mandating steel, concrete, or advanced composites instead?
Exactly. It would be a massive paradigm shift.
We might actually be nearing the end of the era where wood is acceptable for a horizontal water trap.
It's definitely something to think about.
So tomorrow morning, when you step out onto your balcony with your coffee, take a moment to look down.
Think about the internal struts, the joists, the ledger board anchoring you to the building.
And ask yourself,
Well,
is the machine beneath my feet winning its battle against the water